Alright, thanks for tuning in. Brandon Clayton here. Today's lesson, as you can see, write equations parallel or perpendicular to another line. So what are the teaks that cover this? See, here are the two teaks that we want to talk about, A2E and A2F. They're very similar. The only difference is one's asking for parallel, the other's asking for perpendicular. So write the equation of a line that contains a given point and is parallel to a given line. And write the equation of a line that contains a given point and is perpendicular to a line. So do you know what parallel is? Do you know what perpendicular is? Do you know what makes them different in an equation? So that's what we want to look at today. So let's start with this problem here. Find the equation that's parallel to a line. Write an equation that describes a line parallel to the line on this graph. So we want another line that's parallel to this one and goes through point 3,5. So what's the equation of that line? So one of the things we could do is simply just draw it, right? So we could say we got point 3,5 and we want to draw another line that's parallel. Well, parallel means they have the same what? The same slope. So let's find the slope of this line. So we take a point here, we take a point here, and I see that it's going up 2 over 1. So I know that this one's going up 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And what was I looking for? I was looking for this y-intercept. Because I already have the slope, now the y-intercept helps me figure out the whole equation. Because for this line that's yellow, the equation is what? Well, I know the slope is 2, so it's 2x. And what's the y-intercept? -4. But for my other line, let's go ahead and make a line. There we go. So for this line, that's supposed to be an arrow there. What's the equation for this line? Well, this is y equals 2x. Same slope, right? Because they're parallel, but it's different y-intercept at -1. So that's what that's going to look like. Now, what if you couldn't draw it on the graph? How would you solve it? Well, here's what you could have done. And we'll do this here also in the future problems. But we know that our slope is 2x, so we can start off by saying y equals 2x plus some b value. Well, let's take a point. They said 3,5, so we're going to keep the same slope because it's parallel. 2, and we're going to say 3 and put a 5 here and solve for our b. 2 times 3 is 6. And solving for b means I need to subtract 6 on both sides. B is equal to 5 minus 6, which is -1. Guess what we got? -1. So that's another way you could have solved it, because what if you couldn't graph it, didn't want to graph it, or just wanted another way to check it? There's how you would do it. Let's go to a different problem. What if I asked you to do the same thing, everything's the same, but this time find the line that's perpendicular to this line, and that goes through point 3,5. Well, before I go there, let's talk about perpendicular just real quickly. What is perpendicular? Perpendicular means that two lines cross. So these two lines are going to cross and form a 90-degree angle. So there's somewhere the two lines are going to cross. And in this case, actually, let me back up, because we're going to go through point 3,5 right here. So I know that it's going to cross, forming a 90-degree angle. Now, I don't want you to try to sketch that like I just did and try to figure it out, although that's a cool way to get an idea. We want to do it mathematically so we be accurate, because this is not art, this is math. So we want to make sure we get the exact answer. But that's about what it's going to look like. And notice that it forms a right angle. So this right angle. So this line is perpendicular to the yellow. So how do we find the perpendicular line? First, let's practice finding slopes that are perpendicular to another. So what do we mean by that? Well, we know that parallel slopes are what? Equal. They're exactly the same. But what about perpendicular slopes? What can we conclude about perpendicular slopes? So let's practice a little bit. If I give you a slope of 2/3, what's going to be the perpendicular slope? Well, perpendicular slope is found by taking the negative reciprocal of the original. Okay, so we have 2/3. Let's take the negative. And reciprocal literally means to switch the places of the denominator and the numerator. In other words, we're flipping it. But I won't say flip often because I want to use the mathematical vocabulary here by saying reciprocal. So we're going to reciprocate this and go 3 over 2. Now let me try another one. What if I gave you 4/3? What would be the perpendicular slope? That's right, minus 3/4. I hope that's what you said. Sorry, so what if I gave you 3? Well, we know it's going to change the sign, don't we? It's not going to be the opposite. So actually, some would also say opposite, because I'm going to get to that later, because it won't always go negative, because if it's already negative, we'll make it good, positive. So in this case, it's positive, so we make it negative. Well, what does this become? This becomes 1 over 3. Why? Because 3 is understood to have a 1 at the bottom, so we're taking the reciprocal. So that's how we're going to practice it. Now, what if I gave you negative 4/5? What's going to be the perpendicular slope? Well, we got to do the opposite, or the negative of this value, which in this case is changed into a positive, and now we reciprocate it to 5 over 4. What about negative 2? Well, again, we change that from a negative to a positive, and we reciprocate it to 1/2. And lastly, what about negative 3/2? Again, changing that to a positive, reciprocating it to 2/3. So that's the big idea. Now, we could have graphed all that, but we're doing that now, so there's no need to go through that. So let's get back to our problem. All right, now let's apply what we learned coming back to this problem. How do we find the perpendicular equation for this line that's yellow? So let's take our original. We know that our original slope here is 2, right? Because we take 2 points and we count it. We're going up 2 over 1. So that's a positive 2 and 1. So we know it's 2. So if that's the original slope, what's the perpendicular slope need to equal? So my perpendicular slope will have to be opposite sign, in this case is negative, and reciprocated. So reciprocal is negative 1/2. So I could actually take 3/5 right here. I'm sorry, 3/5, 3/5, the point 3/5, and start to apply that slope. So by going down 1 over 2, down 1 over 2, up 1 to the left 2, up 1 to the left 2, and drawing a line. There we go. And this line goes on forever. Draw my little arrows there, and we're done. So that's what it would look like. But where's the wildness up? Is that at a half, or is that another decimal? Who knows for sure? And what if it was off the graph? How would I find out for sure? Well, we can just plug it back into the equation. If you remember, y equals mx plus b. We already know our original slope is 2, but our perpendicular slope is negative 1/2. Negative 1/2. When we're going to take this x value and y value to put it back in here. So we put 3, leave that as b, and a 5 here for my y. Let's solve this for b. Negative 1/2 times 3 is negative 3/2 plus b equals 5. I'm going to add 3/2 on both sides to get rid of that on this side, and do the same thing over here. Negative, add 3/2. So that leaves me with b equals 5 plus 3/2. What is 5? Let's do that somewhere over here. Different color. 5 plus 3/2. Well, in order to add fractions, if you remember, I need the same denominator. So this 1 that's here for the 5 needs to become a 2. I'm going to multiply this by 2 on the bottom to get that, and multiply the top by 2 to give me 10 over 2, which is the same thing as 5. 3 over 2. 10 plus 3 is 13 over 2. So 13 over 2, I'm going to use a decimal to make sure I'm right. Actually, I could just keep it this way. So if I'm writing the equation, I can just leave it just like that and say, now I know the equation. Y for my perpendicular equation here, it's not going to be y equals, I know the slope is negative 1/2 x, and now I know my y-intercept is 13 over 2. And yes, that would be what, 6.5. So right there in the middle. So that was a 0.5, but we didn't have to guess. We found out exactly what it was. All right, let's move on to our next problem. All right, let's try another problem. I want you to pause it here and see if you can work these two more. One was parallel, one is perpendicular. So this one's asking for a parallel line, something that's parallel, a line that's parallel to this line, but goes through 0, -2. Here's my point 0, -2. You can imagine that line is going just like this. What's the slope of this line, first of all? So let me get 2 points. And I'm looking at this, and I see that the slope is going down 1, 2, 3. And to the right, 1, 2. So it's -3/2. Well, guess what? My parallel slope has to be exactly the same. So really I'm done because they already gave me the y-intercept. So I know that for that line, and I should have used that different color, but it's going to be y equals -3/2 x and a y-intercept at -2. -2. So we're done right there. I mean, unless they want us to graph it, we have to do nothing else because that's the equation. Same slope, different y-intercept, and they gave us the y-intercept. So we're really done with that. Let's go to our next problem. All right, what about if I wanted it perpendicular? So if I wanted perpendicular, my original slope of this blue line, we just said was down 3/2, -3/2. So what is going to be, nope, I got to rewrite that, -3/2. So what's going to be my perpendicular slope? It's going to be the opposite sign and reciprocal, right? 2/3. So we still wanted to go through 0, -2. It's going to be right here, but this time the line is going to be moving this direction. So it's going to be going up 2/3, up 2/3. And you can go ahead and graph that if you want to, but really, if they want the equation, we're done because we have everything we need. We have the new slope, 2, 3, 2/3 x, and a y-intercept of 0, -2. So we know it's crossing at -2 there, and that's it. So if we sketched it out just to see it, up 2, 1, 2, 3, up 2, 1, 2, 1, 2, 3. So you can see what that line is going to look like going straight through there. I kind of drew over it, but you get the idea. Let me kind of at least sketch it at least because I went so quickly. Up 2, 1, 2, 3, and here. So here's my line and connecting those dots. You can see that it's clearly perpendicular, right? So that'll make my little square box here for perpendicular 90 degrees. All right, we are going to our star problems. What did it look like on star? Let's work one problem like that. All right, here's what it looked like on a star question a few years back. It says the graph of line G is shown here. Here's line G. What's the equation? Write an which equation describes a line parallel to line G that has a y-intercept of 0, -1? So they're basically giving us the answer if you think about it, because parallel is going to mean the same slope. So what's the slope of this line? They gave you 2 solid points, so let's just use those points to find the slope. So I like to draw a little table to calculate that pretty easily. -4 and 6 and 4 and 2. And when I look at these, it becomes easy to see that we're going down 4 and up 8. So what is down 4 over 8? That's going to be a -1/2. And it should be negative, right? Because that line is going down. I don't like that too. There you go. So it'd be a -1/2. I want parallel, so I'm looking for another line that's parallel. Fortunately, they have them all in y-intercept mode, and it's easy to see which one is not going to be the answer. Matter of fact, before we've even started this problem, we know that the slope is negative, so we could cross out a +2 and a 1/2. Look at that. Just from glancing and saying, oh, this is going down, it's going to be negative. Now we know that our slope is -1/2, and there's no other choice but this one. That's going to make sense. Plus our y-intercept is going to be 0, -1, so we already know it's a -1 here. Everything is pointing to C. So really simple in how to apply that. I think that does it for us. So did we cover everything? Yes, we wrote equations of a line containing a point given its given point and is parallel to a given line and perpendicular to a given line. Guys, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.